Hello, this is lesson 2.2, and we will be talking about linear functions here. So, as the word linear, that first four letters, it says a line. So we are going to be looking at lines. We're going to find the slope of a line. We're going to discuss the slope-intercept form of a linear function, and then we're going to determine whether lines are parallel, perpendicular, or neither. And we're going to write the equation of a line in slope-intercept form. Okay, so let's look at the slope first here. What we've got four different slopes here. So we have a positive slope, which means that it is increasing. So, for example, it might look like this, or it can also be like this. So the slope depends on, or the lines depend on the slope, and but both of these are positive. If you think about starting from the left and walking on the line, you are walking uphill. So that's a positive slope. Now, our next one is a negative slope. So that one, if we start from the left and walk on the line here, we are walking downhill. So it can be like this, or again, it can be like this, as long as it is decreasing. Next, we've got a zero slope. So a zero slope means that it is not rising at all. So it is a horizontal line. The fourth one is undefined, and undefined is when we have a vertical line. Okay, so next we have the slope formula here. So this m here means slope, and it is rise over run. So we can either do rise up and run to the right, or if we're looking at this, it should actually be rise down and run to the left then. Again, remember, if we look at this line right here that we've got in the slope formula, that is, again, a positive slope. So both the rise and the run have to be positive, or both have to be negative to cancel each other out. Okay, so we're going to find slopes here. So we need 2 points on the line. And we're given this point here, which is -3, -3. And then we can see that the y-intercept is 0, -2 right here. So what we're going to do is we're going to go up. So rise is 1, and run to the right 1, 2, and 3. So our slope for this one is 1/3. For this next one, again, we have the same point, -3, -3. Now our y-intercept is 0, -4. So in this case, we're going down 1, so we have to put a -1 over, and then we're going 1, 2, and 3. And that's our slope. it is downhill from left to right, so it has to have that negative sign in front of it. C is the horizontal line right here. And that was where the slope is a 0. So there is no rise, it's just a run. Because the rise is 0, the slope is 0. And anytime we divide 0 by any number, it's going to equal 0. On D is where we have the horizontal, no, I keep confusing. This is a vertical line. We have a vertical line. So we have a rise, but we don't have a run. So run is a 0. And remember, we are dividing by a 0 when we are or dividing by the run when we're calculating the slope. And we cannot divide by a 0. So the slope is undefined for the vertical line. Okay, so that's how you get the slope from the graph. Now we're going to look at the formula. Again, the m here is the slope. It is rise over run. It is the change in y over change in x. This triangle here, the it's delta, means change in. So change in y. And this here is change in x. So we do y2 minus y1 over x2 minus x1. For example, here we can have the point x1, y1, and here x2, y2. Okay, so we're going to calculate, practice calculating with the formula. It does not matter which one is 1 and which one is 2. You just have to keep it consistent so that from the same point, you've got the 1 for the x and the y. So I picked the -4 and 11 to be x2 and y2. So we're going to plug this in. Y2 is 11. Y1 is -2. And now remember again, we are subtracting and we've got the negative in front of the 2. So we have to have both. My x2 is -4 and my x1 is -5. So two negatives make it positive. And again, on the bottom, two negatives make it positive. 13 over 1. So our answer is 13. So our slope for this one is 13, and I ran into the other space. Okay, same thing for this one right here. Again, it doesn't matter which point is x1 and which point is or which point is 1 and which point is 2. I'm just writing them in order. So same thing. Y2 is 0 and y1 is 14. X2 is 3 and x1 is -4. So -14 over 3 plus 4, -14 over 7, which is -2. So our slope is -2. All right, let's move forward. And now, again, I highly recommend pausing and trying to do the calculations on your own, and then again continuing and seeing if you got the correct. So x1, y1, x2, y2. So again, y2 is 8, y1 is 5, x2 is negative 3, and x1 is negative 3. So 8 minus 5 is 3, negative 3 plus 3. Well, over here we have a 0. Again, we cannot divide by a 0. So this one here has to be, or the slope has to be undefined. I drew a line and then I don't, then I go over it. Undefined. Because we are dividing by a 0. Let's look at this one here. What would the last two lines look like? So remember, this one, we're rise over run, so it doesn't have a run. So that means that this line, well, we can graph or plot the points. Negative 3, so negative 1, negative 2, negative 3. And then we've got 1, 2, 3, 4, 5. So negative 3 and 5 is here. And then negative 3 and 8, oops, mine doesn't go enough. 6, 7, 8. So is over here. So when I go ahead and graph the line between those 2 points, it looks like this. So there's your vertical line. Okay, let's look at the other one. Again, x1, y1, x2, y2. And you should get the same, I mean, the slope doesn't change, even if you do change, make negative 3, 5.2. And 2, 5 is 1. It doesn't make a difference. Okay, 5 minus 5 over 2 minus negative 5. Now we get a 0 on the top and a 5 on the bottom. So 0 divided by any number is going to be a 0. So for this one, m is going to be 0. Okay, so let's graph it. We have a negative 3, 1, 2, 3, and 5, 1, 2, 3, 4, 5 is over here. So that's our point. And then we have 2, 5. There's our line, which is a horizontal line. Okay, let's move on. And we're going to look at slope-intercept form now. If a line has a slope m and y-intercept b, then it is the graph of the equation y equals mx plus b. This is called the slope-intercept form. You will need to know what is slope-intercept form. We are going to look at other forms as well. Okay, so example 3 is identify the slope and y-intercept. So again, it's y equals mx plus b. M is the coefficient of x, which in this case is 3. B is the y-intercept, which is the number after, and it's negative 2 for this one. Now, you might see the y-intercept written like this, or we've done it where it's a point, 0, negative 2. So those are the two different ways you might see it. Okay, next one here, y equals x. So now when we look at this, we don't have anything here for b. So our b, y-intercept, is going to be 0. So that means that it crosses the y-axis at the point 0, 0. Now, our slope, though, that's not going to be a 0. There is a number in front of the x, which is a 1. We just don't write it. It's like somebody called it understood 1, which makes sense. It is, we understand that there's a 1 in front of the x because the x is there. Or some call it hidden 1. So our slope is that 1. Okay, next one. Um, number 4, identify the slope and y-intercept of each line. So we keep doing the same thing. Now, if we look at this form right here, that is not in the slope-intercept form. So what we want to do is put it in the slope-intercept form before we can identify the slope and the y-intercept. So we want to isolate the y. So we're going to start by subtracting 2x from both sides. We get negative 9 minus 2x plus 9. Then we have the negative 1 in front of the y, or just the negative. We're going to divide all of these by negative 1. So we get y equals 2x minus 9. Now we have it in the slope-intercept form. And now we can say that our slope is 2 and our y-intercept is negative 9. I did not circle my answers here. Okay, next one. Y equals 3. Okay, so here, if we think about it, y equals mx plus b. Well, we don't have, all we have is a number, a constant here. So that has to be b equals 3 then. It doesn't have the x. So if it doesn't have the x, then that means that our slope has to be a 0 because y equals 0x plus 3. Well, this here has to be a 0. So it ends up only being y equals 3. So our slope is 0 and our y-intercept is 3. Well, this one here, C, x equals 5, we don't have a y. So what does that look like if we graph it? So there's x equals 5. It means that it would be a vertical line. And we remember that a vertical line, the slope is undefined. And as you can see from the picture, it does not cross the y-axis at all. So there is no y-intercept for this one. Okay, next we're going to look at parallel and perpendicular lines. Let me see. I have not used it. Okay, and never mind. Let me just draw by hand. Just to, yeah. So parallel lines. Parallel lines are next to each other, side by side, and they go in the same direction. So there's a lot of different options for parallel lines. They never touch, so they have the same slope. Now, perpendicular lines are the ones that intersect each other in a 90-degree angle. That should be a square, a 90-degree. And again, they can be any way what matters is that there's a 90-degree angle. So they have a 90-degree angle. And so their slopes are opposite sines and reciprocals. So we're going to look at examples. What does that actually mean? So we need to determine if the given lines are parallel, perpendicular, or neither. Now, the slope of this first one is a 2. Slope of the second one is a -2. Now, these are not same. They have opposite signs, but they are not reciprocals. So this means that the lines are neither. They're not parallel or they're not perpendicular. For our B, the first one, m is 3, and the second one, m is -1/3. Now, opposite signs, yes. This one is a plus and that one is a negative. And now, the top one here, actually, let me, to erase it. Let me, so the top one here, we can write any number as over 1, right? So when we do the reciprocal, we flip it over. So the reciprocal of 3 would be 1/3. And since it's the opposite sign, it means that these are perpendicular. Okay, C. The top slope is 7 and the bottom slope is 1/7. Well, they are reciprocals, but they are not opposite signs. So these are neither. D, the top slope is 5 and the bottom slope is 5. So that means that they are parallel because the slopes are the same. Okay, next. So this was the slope-intercept form that we looked at over here. Now we're going to look at point-slope form. So when you know the slope of the line and you know one point, that is when we're going to use the point-slope form here. So example 6, we have the slope, which is -2, and we have 1 point, -3, 4. We're going to plug it into the point-slope form. Y doesn't change. So this is x1 and y1. So y minus y1 is 4 equals our slope m is -2, and then parentheses x minus -3 and close. Now, this is the point slope form. What we want to do is we do want to, hold on, that's wrong. This should be point slope form. We want to get rid of one set of parentheses. So we're combining the negative signs, which are back to back, and putting it as x plus 3. So this is your point slope form. Okay, let's do another one. Again, x1, y1. So 1 minus -1 equals, our slope is 3, x minus -2. And again, we need to get rid of those back-to-back negative signs. So y plus 1, 3x plus 2. And that would be your point slope form. Okay, so to write the equation of a line in slope-intercept form, do you have a slope m? So what you need for the slope, in order to calculate the slope, you need 2 points. When you have 2 points, you can calculate the slope. Then, do you have a y-intercept, 0b? So if your answer is yes, then you can write it in the slope-intercept form, y equals mx plus b. If your answer is no, then you're going to use the point slope form. And solve for y. Because we're asked to use the slope-intercept form here, that's why we're solving for y. We didn't do it in the examples above because we were not asked to do it for, we were supposed to just do it in point slope form. Okay, so let's look at how we do this. So for example 7, we've got problems that are in point slope form. Let me just do this so that I might hopefully not cross lines. We'll see. That's not guaranteed. Okay, so our first one, we have a point and we have a slope. So, and we need to write these in slope-intercept form, which is the y equals mx plus b. So this first one is easy. It has the y-intercept because x is 0. So y equals, our slope is 8/5 x plus 5. So this here is b. And that's it. It was that easy. Now, this next one, be careful now. We have a slope, but we don't have a y-intercept. We have a point here. So that's when we're going to use the point slope form. So the y minus y1 equals, m times x minus x1. Okay, so we're going to go ahead and plug in y minus our y, so x1 and y1 is 2 equals 6 times x minus negative 3. Again, we need it in slope-intercept form, so we're going to solve for y. So y minus 2, we need to get rid of these parentheses first. Distribute 6 6 plus 18, and then add 2 to both sides. So we get y equals 6x plus 20. And there we go. Okay, next one. We have 2 points. So we need our slope. 8 minus 5, 0 minus 3. 3 over negative 3 is negative 1. So our slope is negative 1. Now, when we're looking at these points, remember, this is x. That's a 0. So we know that this is our y-intercept. So we can actually go ahead and just plug that in instead of using the point slope form. Y equals negative 1x plus 8. And now we don't write the 1. we just do y equals negative x plus 8. Okay, next one. We've got 2 points, so we need to calculate our slope again. So 7 minus 1, 2 minus negative 1. We get 6, 2 plus 1, so 6 over 3 equals 2. That's our slope. When we're looking at those points, we can't, we don't have a y-intercept, so we need to use our point slope form. And now we can just pick one point, whichever point you find easier. I like the ones. It just easier calculations. So y minus 1 equals 2x minus negative 1. The only thing is you'll get the same answer from either point. You just have to stick with one point and not mix those coordinates. So y minus 1 equals 2x plus 1. We distribute y minus 1 equals 2x plus 2, and then we add 1. So we get y equals 2x plus 3 as our answer. Okay, next. Um, we have the point 0, 0.08 and perpendicular to 2/3 x minus 3. Okay, so this slope right here is 2/3. Perpendicular, remember, we opposite sign, so a negative, and then we flip this over. We take the reciprocal. So it ends up being 3 over 2. So that is our slope. Now, looking at this point, yes, it's never wrong to use the point slope form and you'll get the same answer. But again, we have the b right here because x is 0. Again, if you go and plug it in the point slope form, you'll get the exact same answer. So y equals negative 3 over 2x plus 8. Okay, one more. So we have a 0.52 and it's parallel to y equals negative half x plus 6. So this slope is negative half. Now, it's parallel, so the slope has to be the same. Our point is not the y-intercept, so we're going to have to use point slope form here. So y minus 2 equals negative half x minus 5. Y minus 2 equals negative half x plus 5 over 2. Okay, we're adding 2 fractions. Um, so let me do this on the side here. So 2, if we want to write it as halves, 2 times 2 is 4, so it's 4 over 2. So then 4 plus 5 is 9, so it's 9 over 2. So we can leave it in this form, or we can make the 9 over 2 a mixed number, which is 4.5. Okay, that's it for today. Let me know if you have any questions on anything. Um, you are, you can email me or ask me in class. Bye.